Tonight, if the sky above you is clear, I want you to do something very simple. Step outside. Put your phone away for a moment. Don't look for constellations or planets or anything specific. Just look up. Human beings have been doing this for tens of thousands of years, long before telescopes, before physics, before we even had words for what we were seeing. And there's a strange feeling that comes with it. Quiet. Difficult to explain. Not mystical exactly, but deeply human. The night sky has a way of making you aware of your own size in the universe, not in a depressing way, but almost in a freeing way. For a brief moment, the pressure of ordinary life loosens. The problems shrink. The constant tension we carry without noticing becomes lighter. I've spent most of my life looking at the sky, sometimes through equations and instruments, sometimes simply as a person standing outside in silence. And over the years I've noticed something that I think deserves serious attention. The sky does not look the same anymore. I don't mean emotionally or nostalgically, I mean scientifically, objectively. The universe is behaving in ways our current theories struggle to explain, and the instruments we've built are now sensitive enough to notice it. Of course, the universe has always changed. Stars are born and die. Galaxies move apart. Space itself expands. Cosmology has taught us that nothing in the universe is fixed forever. But normally these changes happen over billions of years. No human being notices them directly. What we are seeing now is different. These are changes happening on timescales we can actually measure within a generation. Patterns appearing in the data that should not be there according to our best understanding of physics. And this is where honesty matters. When scientists encounter unexplained observations, there are usually two bad reactions. The first is sensationalism. People rush to revolutionary conclusions and declare that physics is broken or reality itself has changed. That kind of excitement often outruns the evidence and damages trust. But the opposite reaction is just as dangerous. Dismissing anomalies simply because they are inconvenient, saying the instruments must be wrong, saying the current models are good enough. That is not scientific rigor, it's intellectual avoidance. Because when strange results continue appearing across different telescopes, different teams, and different methods, and when those anomalies become stronger as measurements improve, we have to pay attention. That does not mean we throw away everything we know. But it does mean we stay open to the possibility that something fundamental is incomplete in our understanding of the cosmos. One of the clearest examples is something called the Hubble tension. This may sound technical, but it points toward one of the deepest problems in modern cosmology. The Hubble constant measures how quickly the universe is expanding. It is one of the most important numbers in physics. The problem is that depending on how we measure it, we get two different answers. When scientists calculate the expansion rate using the early universe, especially the cosmic microwave background, the ancient light left over from shortly after the Big Bang, they get one value. But when they measure the nearby universe using supernova explosions and galactic distance markers, they get a value roughly 8 or 9% higher. That difference may not sound enormous, but in cosmology it is massive. And the more carefully researchers measure it, the more stubborn the discrepancy becomes. If the expansion rate is truly different from what we expected, then our entire timeline of cosmic history may need revision. The age of the universe, the way galaxies formed, the behavior of dark energy, all of it depends on that number. Scientists have proposed many explanations. Some suggest new forms of energy in the early universe. Others suggest unknown particles or changes in dark energy over time. Some think gravity itself may behave differently on enormous cosmological scales. And yes, it is still possible there's a hidden measurement error nobody has found yet. But after years of increasingly precise observations, no one has identified a mistake large enough to explain the tension away completely. And that is why people are paying attention. At the same time, another mystery has emerged from the James Webb Space Telescope. Webb is finding galaxies in the early universe that should not exist so soon after the Big Bang. These galaxies appear massive, mature, and highly structured at a time when the universe was supposedly still too young for them to form. According to our models, there simply wasn't enough time. Matter should not have organized itself this quickly. Stars should not have formed so efficiently. Yet the observations continue appearing again and again. The early universe seems to have evolved much faster than expected. Then there are the strange, large-scale structures of the cosmos itself. Enormous walls of galaxies, giant cosmic filaments, alignments stretching across distances so vast that known physics struggles to explain them. Some regions of the universe appear more organized than they should be if the cosmos is truly uniform in every direction. None of these discoveries alone proves our theories are wrong. But together, they form a pattern that is becoming harder to ignore. And history tells us something important about moments like this. Some of the greatest breakthroughs in science began as small anomalies that refused to disappear. Tiny deviations in Mercury's orbit eventually led Einstein toward general relativity. Strange behavior in blackbody radiation helped create quantum mechanics. The universe often whispers before it shouts. The question is whether we are listening carefully enough. And if these anomalies are pointing towards something deeper, then what exactly are we beginning to see? Because the answer may force us to rethink not just cosmology, but the very nature of space, time, and reality itself. What if the universe is not behaving strangely by accident? What if the anomalies appearing across modern cosmology are not isolated errors, but early signs that our deepest assumptions about reality are incomplete? That possibility may sound extreme at first, but history shows that science changes exactly this way. The universe begins by giving us small contradictions, tiny cracks in the model, and over time, if those cracks refuse to disappear, an entirely new understanding emerges from them. Right now, many physicists believe we may be standing at one of those moments again. The most conservative explanation for the strange observations is that dark energy behaves differently than we thought. Dark energy is the mysterious force driving the accelerated expansion of the universe. In our standard cosmological model, dark energy is treated as something constant, a fixed energy built into empty space itself. Einstein originally introduced this idea through the cosmological constant, and for decades, it seemed to fit the observations reasonably well. But there has always been a problem with that explanation. We don't actually know what dark energy is. We can measure its effects, but we do not understand its nature. And because of that, some physicists are beginning to wonder whether dark energy is not constant at all. Instead, it may evolve over time. It may have behaved differently in the early universe than it does today. Some theories describe it as a dynamic field called quintessence, something changing slowly across cosmic history. If that is true, then many of the current tensions in cosmology suddenly make more sense. The universe may have expanded differently in its earliest stages than our models currently assume. Galaxies may have formed faster. Large structures may have emerged earlier. Even the disagreement in the Hubble constant measurements could be connected to this deeper change in cosmic expansion. But there is another possibility, and this one is far more radical. What if gravity itself changes at enormous scales? General relativity remains one of the most successful theories ever created. Einstein's equations have passed incredibly precise tests within our solar system. We've confirmed them using black holes, gravitational waves, neutron stars, and orbiting satellites. The theory works astonishingly well, but nearly all of those tests happen at relatively local distances compared to the size of the universe. When we examine scales billions of light years across, our measurements become far less precise. And some modified theories of gravity predict exactly the kind of anomalies we are beginning to observe. Slight deviations in gravity on cosmological scales could alter how galaxies form, how structures evolve, and how space itself expands over time. In other words, Einstein may not have been wrong. His theory may simply be incomplete in the most extreme environments imaginable. There is also a third possibility that many cosmologists are taking increasingly seriously. The universe may not be as uniform as we assumed. Modern cosmology relies heavily on something called the cosmological principle, the idea that the universe looks roughly the same in every direction when viewed at large enough scales. This assumption simplifies the mathematics enormously and has worked remarkably well for decades. But what if the universe contains enormous structures and directional patterns larger than expected? What if the cosmos is only approximately uniform instead of perfectly so? Then many of the tensions we observe today may come from applying a simplified symmetry too rigidly to a far more complicated universe. And then we reach the deepest possibility of all, the possibility that these anomalies are echoes from the very beginning of existence itself. This is the idea that excites many theoretical physicists the most, not because it is proven, but because it touches the deepest unanswered question in science. What happened during the earliest moments of the universe, when space and time themselves were still quantum mechanical? Our current theories break down there. General relativity describes gravity beautifully at large scales. Quantum mechanics describes particles beautifully at microscopic scales. But when we try to combine them at the birth of the universe, the equations stop working. The Big Bang represents a boundary where our understanding becomes incomplete. And that matters because the early universe was not just hot and dense. It existed in a regime where quantum gravity may have shaped everything. Some physicists believe the strange observations we are now detecting could be fossilized traces of that unknown physics. Tiny signatures left behind by processes occurring when the universe itself was less than a fraction of a second old. That possibility changes the meaning of modern cosmology completely. Because suddenly, the sky is not merely showing us distant objects. It is preserving clues from a realm of physics we have never directly accessed before. A realm where space-time itself may not be smooth or continuous the way it appears in ordinary life. This is one of the central ideas emerging from theories like string theory and the holographic principle. At the deepest level, space-time may not be fundamental at all. It may emerge from something even more basic, something relational, quantum, and profoundly different from our everyday intuition. If that is true, then the earliest universe operated according to rules we still do not fully understand. And the structures we see today, galaxies, clusters, cosmic filaments, may still carry subtle imprints from that ancient regime. Now we have instruments capable of detecting those imprints. The James Webb Space Telescope, the Atacama Cosmology Telescope, the Planck satellite, large-scale galaxy surveys mapping the cosmos in unprecedented detail. Humanity has reached a point where our tools are finally sensitive enough to notice things previous generations could never see. And what we are finding is deeply interesting. The universe is not fitting neatly into the picture we expected. But there is something important I want to say here. Genuine science does not panic in moments like this, nor does it become arrogant. The correct response to mystery is disciplined curiosity, to look carefully, to stay honest, to resist both sensationalism and denial. Because sometimes the universe changes our understanding quietly, not through dramatic revelations, but through persistent evidence that slowly forces us to rethink the foundations beneath our assumptions. And maybe the most extraordinary part of all this is that we are alive during one of those moments. A period when human beings have become capable of looking deeply enough into reality to discover that reality is still stranger than we imagined. But the deeper I've thought about these cosmic mysteries, the more I've realized they connect to something surprisingly personal. Because watching the sky change over time also changes the way you think about your own life, your relationships, and the fragile nature of human attention itself. There was a night years ago that I still think about often. I won't tell you exactly where or exactly when, because those details are not really the point. What matters is that the sky was unbelievably clear. No city lights, no noise, just darkness, filled with stars stretching farther than the mind could comfortably hold. I remember standing there, not thinking about equations or theories or cosmology, but simply looking. And while I stood there, something became painfully obvious to me. The sky I was looking at was temporary. Not temporary in the human sense, where things last a few years and disappear. Temporary on cosmic scales. The stars above me were changing even as I watched them. Galaxies were moving apart. New stars were forming somewhere else, while older stars were dying. The exact arrangement visible from Earth in this era of history would not exist forever. 1 billion years ago, the sky looked different. 1 billion years from now, it will look different again. And strangely, that realization did not feel depressing. It felt clarifying. There is something deeply calming about understanding that everything is temporary. Not because nothing matters, but because permanence was never the requirement for meaning in the first place. A moment does not need to last forever to be real. A relationship does not need to survive eternity to matter. The sky itself teaches that lesson if you look long enough. I think about that now whenever I think about cosmology and the expanding universe. Physicists talk constantly about the large-scale expansion of space, galaxies drifting farther apart over billions of years, distances growing slowly but relentlessly until, in the unimaginably distant future, most galaxies will disappear beyond the observable horizon entirely. Eventually, the night sky itself will become darker, not because the stars all die at once, but because space expands faster than their light can continue reaching us. Future civilizations, if any still exist, may look into the cosmos and see almost nothing at all. They may never even know the universe was once filled with galaxies. For most of my career, I understood this as a scientific fact. But over time, I began to recognize it as something else too. A metaphor for human life. Because the same kind of expansion happens between people, not dramatically most of the time, not through fights or betrayals or obvious endings. Usually it happens quietly, slowly, almost invisibly. The distance between two people grows not because either one intended it to, but because attention drifted elsewhere. Time filled itself with other priorities. The gravitational force that once held the connection together weakened gradually. There's a concept in cosmology called the Hubble flow. Galaxies move apart because the space between them expands. Nothing is pushing them away directly. The medium itself is stretching. And I've watched something similar happen in ordinary human relationships. Friendships, families, marriages. People who were once deeply connected slowly drift apart because the space between them is no longer actively held together by attention, presence, and care. The expansion is subtle at first, easy to ignore, but eventually the distance becomes large enough that you suddenly realize how far apart you've grown. And by then, sometimes, the drift already feels irreversible. I say this because I think many people misunderstand what serious intellectual work can do to a life. There's a particular loneliness that comes from living constantly inside ideas, especially ideas about reality itself. Physics is not just information when you spend decades inside it. It becomes a lens through which you experience existence. Questions about space, time, quantum gravity, entropy, black holes, the beginning of the universe, these ideas stop feeling academic. They become part of your inner world. And that inner world can become difficult to share. Not because the concepts are impossible to explain, but because the experience of living inside those questions all the time is hard to communicate. You can describe quantum mechanics to someone. You can explain the Hubble tension or the holographic principle. But the feeling of carrying those questions constantly in your consciousness, the way they shape perception itself, that's different. It creates distance sometimes, not superiority. I want to be very clear about that. Intellectual obsession does not make someone better than anyone else, but it can make them elsewhere, mentally absent, half inside another world even while physically present. And if you're not careful, that distance spreads quietly through the rest of life. I know this because I've lived it. There is a seductive quality to difficult intellectual work. Physics problems feel structured. Even the hardest questions have a kind of clarity. There are equations, frameworks, methods. Human relationships are messier, less predictable, less controllable. The emotional complexity of real life often feels more difficult than abstract thought. And because of that, it becomes dangerously easy to allocate more attention to ideas than to people. At first, it feels noble, serious, disciplined. You tell yourself you are committed to meaningful work, and maybe you are. But over time, the people around you feel the imbalance even if nobody says it out loud. They feel when your attention is partial. They feel when your mind remains somewhere else long after your body entered the room. Relationships evolve according to what they are given. A relationship receiving consistent attention develops one way. A relationship surviving on leftovers develops another. The difficult part is that you rarely notice the change while it's happening. The stars in the constellations appear fixed too, yet over long enough periods they drift apart completely. The patterns we treat as permanent are often temporary alignments viewed from a specific moment in time. Human life works the same way. And one day you look around and realize the configuration changed while you were focused elsewhere. That realization does not always arrive dramatically. Sometimes it arrives quietly, in the middle of ordinary life. A conversation that feels unfamiliar, a silence where intimacy used to exist, a sense that the emotional geometry of your world has slowly rearranged itself while you were busy studying other mysteries. And the honest response to that realization is not guilt. It is revision. The same openness required in science when data no longer fits the model. The willingness to admit the picture was incomplete. The willingness to pay attention again before the distance becomes too large. Because the truth is, the universe is not the only thing constantly sending us signals. The people around us are too. And if we ignore those signals long enough, eventually they fade beyond reach, just like galaxies disappearing over the cosmic horizon. But there's something even deeper hidden inside this connection between cosmology and human life. Something about attention itself, about how we choose what matters, and why the universe may be teaching us the same lesson over and over again. The longer I've spent studying the universe, the more I've come to believe that attention is one of the most powerful forces in human life. Not attention in the shallow modern sense of notifications and distractions, but real attention. Sustained attention. The kind that allows you to truly see something instead of merely looking at it. Science depends on that kind of attention. So do relationships. So does any meaningful life. And yet attention is finite. That may be one of the hardest truths to accept. We like to imagine we can give ourselves fully to everything at once. To work and family and ambition and curiosity and presence and love without compromise. But life does not really work that way. Every hour spent somewhere is an hour not spent somewhere else. Every deep commitment creates absences elsewhere, whether we intend it to or not. Physics taught me this in a strange way. When you spend decades thinking about fundamental questions, questions about space-time and quantum mechanics and the origin of reality itself, you slowly begin to live inside very long time scales. Human urgency starts to feel smaller compared to cosmic time. Entire civilizations become brief events compared to the lifespan of stars. Human conflicts begin to look temporary against the age of the universe. There's wisdom in that perspective, but there's also danger. Because when everything becomes cosmological, ordinary life can start to feel less important than it actually is. You begin unconsciously treating the immediate world as secondary. The work becomes primary. The questions become primary. The search becomes primary. And slowly, without realizing it, you start postponing parts of your actual life for some future moment that never fully arrives. I think many people do this in different ways, not only scientists. Some people disappear into careers, some into ambition, some into survival, some into distraction, but the mechanism is often the same. We convince ourselves that the important human moments can wait while we handle something more urgent, more productive, more intellectually demanding. But time does not pause while we are busy. That is the part nobody escapes. The universe itself demonstrates this constantly. Every structure in existence changes over time. Stars exhaust their fuel, galaxies collide, black holes evaporate slowly through Hawking radiation. Even atoms are not eternal. Everything evolves. Everything drifts. Nothing remains frozen simply because we are too distracted to notice it changing. Human relationships obey the same principle. People change while we are occupied elsewhere. Parents age. Friendships thin out. Children grow up. The emotional architecture of a life rearranges itself continuously beneath the surface of ordinary routines. And if your attention is permanently directed somewhere else, you often discover those changes only after they have already become irreversible. That realization can be painful. Not dramatic in the cinematic sense, more quiet than that, more subtle. It arrives in moments where you suddenly understand that certain versions of your life existed only briefly, and while they were happening, you assumed they would always be there. I think about this whenever I think about the observable universe.